There are times when the universe behaves exactly as our scientific models predict. Every observation aligns with the equations, every measurement strengthens the foundations of physics, and every discovery fits neatly into the framework humanity has spent centuries building. Then there are the moments that refuse to cooperate. The rare moments when reality seems to ignore the rules we believed were unbreakable. Moments that leave scientists staring at the data, questioning not only their conclusions, but the assumptions behind them. Voyager 1, the most distant spacecraft ever built by humanity, has entered one of those moments. For nearly 5 decades, this remarkable explorer has traveled farther from Earth than any human-made object in history. It has crossed the giant planets, escaped the Sun's protective influence, and ventured into a region of space no spacecraft was ever expected to survive. Beyond the Heliosphere lies an environment flooded with cosmic radiation, extreme cold, and conditions unlike anything experienced within our solar system. Against all expectations, Voyager continues to communicate. But recently, something extraordinary appeared within the data. It was not ordinary radio interference. It was not random background noise. It was not a simple disturbance caused by charged particles drifting through interstellar plasma. Instead, researchers found a signal with organization, repetition, and an internal structure that seems strangely deliberate. It behaved less like a random event and more like a response. Imagine releasing a message in a bottle into an endless ocean, expecting it to drift forever through empty waters. Now imagine discovering that someone found that bottle, opened it, and quietly placed a reply inside before sending it back. That unsettling possibility captures why Voyager's newest observations have drawn so much attention. This aging spacecraft, powered by a steadily weakening plutonium generator and controlled by technology designed in the 1970s, has spent decades carrying humanity's presence into the darkness beyond our planetary neighborhood. Now, according to this remarkable narrative, it may have encountered something no mission was ever prepared to explain. To understand why this possibility has captured so many imaginations, we first have to retrace Voyager's incredible journey, from the towering storms of Jupiter and the magnificent rings of Saturn to the frozen worlds of Uranus and Neptune, before finally entering the silent depths between the stars. Only then can we appreciate why this latest mystery feels so unsettling. When Voyager 1 lifted off in 1977, its mission seemed surprisingly modest by today's standards. Engineers expected it to perform close flybys of Jupiter and Saturn, transmit valuable scientific data, capture detailed images, and eventually fade into silence as its power slowly disappeared. No one imagined it would still be operating nearly half a century later. What began as a planetary exploration mission gradually transformed into the longest continuous expedition ever undertaken by a human-made machine. Equipped with a 3.7-meter communications antenna, a small collection of thrusters, and radioisotope power systems that lose energy a little more every year, Voyager was never designed for an endless voyage into interstellar space. Yet today it remains more than 155 astronomical units from the Sun, still returning information from a place no previous spacecraft has ever explored. Most of its original scientific instruments have already been switched off to conserve precious power, leaving only a handful still functioning. Even so, those remaining systems continue to reveal discoveries about deep space that scientists once believed would remain forever beyond our reach. By modern standards, Voyager's onboard computer is astonishingly simple. Its memory is tiny compared to even the most basic smartphone, and it lacks the advanced computing systems found on today's spacecraft. Yet endurance has become its greatest achievement. Year after year, the probe continues to survive an environment filled with intense radiation, magnetic turbulence, and unimaginable isolation. It has become far more than an aging spacecraft. It is humanity's lone observer in a region where no human-built machine was ever expected to travel. That is exactly why every unexpected transmission deserves careful attention. Throughout its mission, Voyager repeatedly surprised scientists. It transformed our understanding of Jupiter, Saturn, the outer planets, and eventually the boundary separating our solar system from interstellar space. But according to this account, none of those discoveries compare with what may have happened next. Voyager's first encounter with the truly unexpected did not happen beyond the solar system. It began much closer to home, during its historic approach to Jupiter. What the spacecraft discovered there transformed planetary science almost overnight. The giant planet was far more violent than anyone had imagined. Towering storms larger than entire worlds churned across its atmosphere. Immense flashes of lightning illuminated clouds with an intensity far exceeding anything observed on Earth. On the volcanic moon Io, gigantic eruptions launched fountains of molten material hundreds of kilometers above the surface, while Jupiter's immense radiation belts pushed Voyager's instruments close to their operational limits. Instead of finding a predictable gas giant, scientists encountered a world overflowing with extreme energy and constant change. Hidden within that complexity were a handful of unusual measurements. Among the intense electromagnetic activity were faint repeating fluctuations that did not appear to match Jupiter's rotation, its magnetic field, or any expected natural cycle. They were subtle enough that researchers at the time regarded them as instrument artifacts or incomplete models rather than genuine discoveries. Years later, those forgotten observations would receive a second look. As investigators revisited decades of archived data, some noticed intriguing similarities between those early anomalies and patterns appearing much farther from the Sun. Whether connected or simply coincidental remains uncertain, but the possibility has fueled renewed curiosity about Voyager's earliest discoveries. If those tiny irregularities represented the first unanswered question, then everything that followed only deepened the mystery. Saturn marked the final major destination of Voyager 1's planned mission. Its graceful rings displayed astonishing detail, revealing delicate wave patterns shaped by gravity and hidden interactions between countless icy particles. The spacecraft also provided humanity with its clearest view of Titan, whose dense orange atmosphere concealed a surface that would remain mysterious for many years. Yet Saturn represented more than another scientific triumph. It was the turning point that sent Voyager permanently away from the familiar architecture of the solar system. After completing its close flyby, the spacecraft followed a trajectory from which there would be no return. With every passing year, the sun became fainter, communication delays grew longer, and the comforting influence of the solar wind weakened. The orderly rhythm of the planet slowly disappeared behind it. Ahead stretched a region that no spacecraft had ever explored, a place where magnetic fields, radiation, and plasma behaved in ways scientists could only estimate through theory. Looking back, Saturn almost feels like the final chapter of one story before the beginning of another. While Voyager 1 departed toward interstellar space, its twin spacecraft continued its own remarkable journey. Voyager 2 became the first and only spacecraft to visit Uranus and Neptune, revealing worlds unlike anything previously seen. Uranus appeared astonishingly unusual, rotating almost on its side as though some ancient collision had permanently tipped the planet over. Its atmosphere remained bitterly cold, its faint rings circled quietly through darkness, and unexpected storms emerged despite receiving only a tiny fraction of the sunlight that reaches Earth. Farther outward, Neptune proved even more dynamic. Powerful winds raced through its atmosphere at incredible speeds, making them the fastest known anywhere in the solar system. Massive storm systems formed, evolved, and vanished with surprising unpredictability, reminding scientists that even distant frozen worlds could possess remarkable energy. Triton, Neptune's largest moon, offered another surprise. Instead of remaining frozen and inactive, it displayed towering plumes of nitrogen gas erupting from beneath its icy surface, creating one of the most unexpected geological discoveries of the mission. The deeper humanity explored, the more extraordinary the solar system became. Researchers proposed that inside these distant ice giants, enormous pressures could compress carbon into crystals, creating conditions where diamonds might slowly form and sink through their interiors. Each discovery reinforced the same lesson. Nature was capable of producing environments far stranger than imagination alone had predicted. Worlds could rotate at impossible angles, sustain supersonic winds, unleash towering cryovolcanoes, and hide exotic forms of matter beneath layers of ice and gas. If such extraordinary phenomena existed within our own cosmic neighborhood, what unimaginable conditions might await beyond the Sun's protective influence? That question would soon become far more than theoretical. As Voyager continued outward, it approached one of the most important frontiers in modern astronomy. The vast boundary where the influence of our Sun gradually fades into the immense environment between the stars.